In this video, we will look at the encryption problem caused by the technological shift to quantum computers, its solution, and some of the other benefits brought by quantum computers. Let's begin by looking at encryption. What is encryption? When data is sent between two parties, it must be jumbled up so that if it is intercepted, it cannot be instantly understood. To turn our unencrypted data into its encrypted form, a key is used. This is called the public key. Once the data has been received, a different key is used to decrypt the data. This is called the private key. If the private key is intercepted, the data is susceptible to breach. A classical computer will never break this, even over the entire time span of the universe. But a quantum computer can break it in just a few minutes. So why do we need a solution? As mentioned in the previous video, as quantum computers become more accessible to consumers, our current encryption can be broken. Encryption is based on a concept called prime factorization. This is when we factor a number so that all of its factors are also prime numbers. Multiplying prime numbers together is not a very computationally heavy task, but factoring them is. Let's try a simple example. Take the number 589. Pause the video and try to split this number into its largest prime factors. 589 can be factored into 19 and 31. If you got the answer, congratulations! This is a complex task which does require a lot of time, even with a computer. If we have a 256-digit long number which we need to split, this can take even the best supercomputers a very long time, but it will not take a quantum computer long. So what is our solution? Fortunately, we already have one, called quantum key distribution. It allows two parties to share a randomly produced private key which is used to both encrypt and decrypt data. This key takes the form of a packet of light which is sent on a separate channel to the data. The packet of light, or photon, has a defined state when it is transmitted. If a third party observes our photon, this state will change, and we can see that the encryption has therefore been broken. Now that we have solved the encryption problem, we can look more at the huge benefits that a quantum computer can provide. First off, let's look at artificial intelligence. This is the development of a computer system which will allow for a computer to complete tasks which usually require a human to complete. This can include decision making and speech recognition. When an AI makes a decision, it will follow a decision tree. In order to populate this tree more, the AI must first attempt to find a solution to a problem. With each iteration, the AI will gain a deeper understanding of the solution to the problem, and will gain a critical thinking capability. Quantum computers will allow for faster data analysis, which will speed up the rate at which an AI can populate this decision tree, leading to smarter AI. This may lead to advancements in the motoring sector, specifically driverless cars, as the car's computer will be able to make better judgment, making it safer for all road users. In addition, we can also expect large strides towards improving our medical capabilities. In 2020, IBM published a report looking at the possible usages of quantum computing within the healthcare sector. They discovered that year on year, the amount of healthcare data is increasing by 36%. Quantum technology will allow for much faster data analysis, as they quote, it can potentially reduce calculation times from years to minutes. IBM identified several potential use cases in this sector. Firstly, diagnostic assistance. Doctors and clinicians may be able to diagnose patients sooner, more accurately, and more efficiently. Drug synthesis is also an area of improvement. A quantum computer will be able to create more complex molecular models which may result in the discovery of new medicines. These are just two areas of improvement, but in general, quantum computing will allow our lifespan to increase, our disease risk to decrease, and the price of healthcare to also decrease. So, with all of this information in mind, it is quite clear to see that the quantum computer will be a catalyst for the foundation and expansion of many sectors over the coming years. Hopefully these videos have helped you to gain an insight into both classical and quantum computing, as well as their wider applications. Thank you for watching.